Valid anagrams. Given two string yes and t, return true if t is an anagram of yes and false otherwise. So basically we are given two string yes and t. We have to check, do both string contain the same letter, do those letters appears the same numbers of time. If yes, return true, if no, return false. So what is mean by anagram? Okay, what is mean by anagram? An anagram means two words or strings that contain the same letters in the same quantity but in a different order. Example, see, we have this L-I, yes, T-E-N, listen, and I have S-I-L-A-N-T, silent. Both words have the same letters. Okay, both words have same letter. I-L-I-S-T-E-N. Okay, L-I-I-S-S-T-T-E-E-N. Both words have same letters, and only the order is different, so they are anagrams. So what these are? They are anagram. Okay, let's take another example. If yes is equal to ANAGRAM and T is equal to NANAGAM. Letter count. Let's count the letters. Just a minute. A has came 1, 2, 3. A has came 3 times. N came 1 time. G 1, R 1, and M is equal to 1. Okay, same letter, same count, same letters plus same counts. So it's a anagram. Okay, only the order is different, so they are anagrams. It's a different order. So let's take another example. Say A. In years, A has came 3 times. Let's take 1. Yes. What is it? A N A G A. Okay. A N A G I N A A. A 3 times. N 1 time. G 1 time. R 1 time. M 1 time. Let's take another example. S equal to R A T and T equal to C A R. Okay, R has came 1 time, A has came 1 time, T has came 1 time. The letters are different. The letters are different, so not an anagram. It's not an anagram. Okay, if two words have same letter with the same frequency, they are anagram. Okay, how can we solve this? Count letters from string yes. Okay, count letters from string yes, subtract letters from string t. If all final counts are 0, then both strings are anagram. If a letter appears 3 times in yes and the same letters appears 3 times in T, so in 3 times A has came 3 times in yes and A has came 3 times in T. 3 minus 3 equal to 0, so it's an anagram. Okay. If anything is not 0, it means extra letter or missing letter, so not an anagram. Let's take this example only. N-E-G-R-A-M and T equal to N-E-G-A-R-A-M. Count letters of S. We put letters of S into a basket and count them. So A has came 3 times, N has came 1 time, 1, 2, 3, and N has came 1 time. G has came 1 time, G has came 1 time, R has came 1 time, and M has came 1 time. So now we know how many times each letter appears in yes. Next, subtract letters of T. Now we remove letter of T from the same basket. Okay, N. 1 minus 1 equal to 0. Okay. And next, A. A has came 3 times. 3 minus 3 equal to 0. This one. Okay, next is G. Next is G. G has came 1 time. G, 1 minus 1 equal to 0. And next is R. R has came 1 time. 1 minus 1 equal to 0. And last one is M. M also came 1 time, so 0. All letters counts are 0. Let's take a pause example. S equal to rat, T equal to car. First we are going to count letters of yes. R has come 1 time, A has come 1 time, and T has come 1 time. Okay, next we subtract letters from T. C. 0 minus 1 because C has come 1 time. 0 minus 1 equal to negative 1. Extra letter. This is a extra letter. Extra letter E. E. 1 minus 1 equal to 0 and R equal to 0. T is still 1. No matching letters in T. C is negative and extra letter. Not all values are 0, so the answer is false. So we count letter of the first string, subtract letters of the second string, and if all counts become 0, the strings are anagram. Add letters of yes, remove letter of T, all 0 true, any non-zero false. Okay, so write on fill in the code. First we are going to create a map. Okay, first we are going to create a map. We create a map called frequency. UNORD unordered map another map int characters. They are characters na, key and value character. Characters letter int how many times the letters appears. We use this map to count letters. Okay, second, count letter of string years. For characters C to S. We go through each letter of string years. Every time a letter comes, we increase its count by 1. If A comes 3 times, frequency of A equal to 3. Okay. Now subtract letters of string T. For now we go through each letter of string T. We decrease the count by 1. If T has the same letter as S, count will become 0. Okay. So check if all counts are 0. Yes, we are going to check all counts are 0. Now we check every letter count in the map. If p dot second is not equal to 0, then return false. If any letter count is not 0, it means extra letter or missing letters, so the string are not anagram. Return false. And then else return true. True. Okay, we have created a map. You can see. Sorry. So that time complexity is big of n. We check all characters 1. Okay, and space complexity is big of 1. Only lowercase English letters. Okay.